Now let's look into internet packet analysis using Wireshark. Now, the project goals are to check real internet packets exchanged and observe network operations using Wireshark. Then, internet packet analysis using Wireshark will be conducted based upon an FTP, a file transfer protocol, file transfer from a Google Drive or a Baidu Drive. And we're going to observe TCP, TLS, UDP, and DNS in action. And we're going to check the location using the obtained IP address. Now, we're going to do the file transfer protocol, the FTP-based file transfer using Wireshark, and the capture packets of the file transfer using Wireshark when you download a file from the Google Drive or a Baidu Drive. You're going to identify TCP and TLS version 1.2, their handshake processes, and you're going to see if any duplicated acts have occurred. In addition, we're going to analyze the average data rate and identify the total elapsed time in the downloading. We're going to start with downloading a file from the below link and capture packets using Wireshark. Now, these are the links that you can use. You can download using Google Drive or a Baidu Drive, and the file size is going to be 500 megabytes. The file name is called download test, as you see right here. Now, this file, download test, is only a dummy file. It's not to be used in any purpose. So just use it for this experiment only. Next, we're going to apply a filter using your IP address in this type of a format in Wireshark. We're going to place it in this location right there. And by doing that in this format where it says ip.addr with an equal equal, and by putting in your IP address, then you can look at the packets that are related to you. Then we're going to identify packets used in the file download and get the Google Drive's server's IP address. And as you can see, normally it's in a form of 216.58.something.something, and in this case you can see the address, it ends with a 200.193. Now, in the Wireshark window, you can see that right down there. And this is the Google Drive server's IP address. And you can see that it's indicated under the source address. So for those packets that were sent to us for the download file test experiment, basically, that's where the packets originated from. Now, you can also identify packets that were used in the download from the Baidu Drive by looking at its server's IP address, which is this in this example. And as you can see here, in this part, you can see the Baidu Drive server IP address. Now, please take note that when you do the experiment, you're going to get a different Google Drive IP address or a different Baidu Drive address. This is just the examples that I experienced when I was doing this experiment. So expect to see a different IP address. Make sure that you write it down and you use it to put it inside the filters in this location right here. Now, step number 4. Another filter you're going to use is your IP address and the server's IP address, which either is a Google Drive or a Baidu Drive, and you're going to combine the commands like this. In other words, right here, you can see this, where it says IP.addr equal equal, that's my IP address, and then you see ampersand ampersand, and then you see another IP.addr equal equal with this address right here. So you put your address over there, ampersand ampersand symbol in the middle, and then you put the server's IP address right here. By doing that, what you're doing is that you're going to filter the packets that include your IP address and the server's IP address. That makes you able to look at only the packets that you exchanged from your computer with the server. Now you can identify the TCP and the TLS handshake between your computer and the server. If you look at the Wireshark window, you can see that the TCP handshake between your computer and the server is denoted. In other words, you can see TCP over there, and right here you can see SYN, SYN-ACK, and ACK, which is the TCP handshake. What does that mean? What is this? Well, between your PC and the server, if you see that the time is flowing in the down direction, it is like this. The PC sends a SYN, which means let's synchronize. And the server replies back with an acknowledgement, okay, I accept your synchronization request, and I'm sending you a SYN, a synchronization request. And that is acknowledged in the last process. This is what you see right here being exchanged. The SYN, SYN-ACK, and then the ACK. In addition, you can look at the TLS handshake, which is included in here, where you see the TLS version 1.2 indicated. In addition, the handshake information shows up in this red box at the bottom. Now, you can see and identify the TCP window size. What this is like this. If you look into the Wireshark window right here, you can see the win information. And you can see the TCP window size is at 307200 size, but then you can see that it changes. It becomes slightly smaller, changing into 305920. The next process is that when the data packets are not transferred successfully, then TCP will trigger duplicated ACKs. And this process can be checked as well. Now, if you look at the TCP duplicated ACKs right here, you can see that it's written in a format where you see TCP duplicated ACK with the missed packet number, then a sharp sign in the middle, and also the number of duplicated ACKs, as in terms right here, 1, 2, 3. These are the numbers that show how many times this ACK has been, this acknowledgement has been repeated. This means that you're experiencing some type of delay in the packet sequence, and therefore the computer is sending out, the TCP inside the computer is sending out messages that are actually checking the status of the data transfer. Next, what we're going to do is we're going to look at the data rate graph. Here, you can look at this, and in the options you can go under the statistics and then select the I/O graph. And in this process, then what we're going to do is we're going to go and look into the server's IP address in the display filter tab and change the y-axis to bytes. What I mean is, first, this is this part right here, where you put your address and you put the server's IP address right here. In addition, you change this part to bytes, which is the y-axis. And now we can check the data rate graph, which looks like this. Now, because you changed the y-axis option to bytes, now you can see that it's in bytes per second. In addition, from the graph, you can see the total elapsed download time, which is approximately 180 seconds, about 3 minutes. In addition, from this graph, you can see that right at this level, this is the average data rate that actually was used to send the file to us. Now, if you use Google Chrome web browser, then sometimes the Google Drive will use a different protocol such as QUIC, which stands for Quick UDP Internet Connection. For example, you will see that if you look at the Wireshark window, and you can see that the QUIC protocol was used. Now let's find the FTP server's location using the IP address. And you can open the web page, which is infosniper.net, which you can see right here. And using that, you can enter the FTP server's IP address right down there, and then you can click on the check button that you see right there. Next, using this information, you can see this type of a map with the information provided over there, which includes IP address, the provider, the host name, the time zone. In addition, you can also see additional information such as the country, the latitude, and the longitude, and other information as well. These are the things that we covered in this project, and I hope you enjoyed it. Thank you.